Hello everybody, and welcome back to the Poor Man's Chemist. It's raining, as you can see, so I've had to bring everything inside here. So in this video we're going to do a simple experiment, and we are going to synthesize sodium metavanadate, and then we are going to use that to produce 24 vanadic acid 2-phosphate. If that compound has another name, I could not find it. But anyway, sodium metavanadate should be fairly easy to synthesize. I've given this reaction a try once before, although I decided when I was doing it just to see what would happen if I added excess sodium hydroxide, and what that gives you is sodium vanadate. Now, sodium vanadate is not a useless compound by any means, and it can be turned into sodium metavanadate because when sodium vanadate is dissolved in water, that will set up an equilibrium between orthovanadate and pyrovanadate, and then pyrovanadate will react with CO2 to produce metavanadate. However, you can end up with all kinds of polyvanadates in solutions, so it's going to be better, I think, just to synthesize sodium metavanadate from the get-go and go with that. You could do sodium vanadate using this exact same synthesis, again, just using excess of sodium hydroxide in the solution. But anyway, we are going to use a stoichiometric amount, and you can see the reaction at the bottom of the screen that we're going to be doing. And so this comes from a wiki-style website that's all about growing crystals, and I will leave a link to it in the description. It is really cool, actually. I don't know how I haven't come across this before, but that's where I got this reaction from. Although it's very straightforward and it's very simple. We're going to take 4.4 grams of sodium hydroxide that's already weighed out, and we're going to create a concentrated aqueous solution, and we're going to stir it up here, and then we are going to add 10 grams of vanadium pentoxide slowly. The reaction is fairly vigorous and quick at first, but it quickly starts taking a while. The instructions say that once all of this has been added, to boil it for several minutes, then allow it to cool, and then we are going to precipitate it by adding ethanol to the mix. Now, if you want to go ahead and make sodium vanadate, the orthovanadate, for whatever reason, it also is insoluble in alcohol, so you can, again, precipitate it out that way. And they're both white powders, although I think that the metavanadate is supposed to be off-white and sort of yellowish, so I guess its impurity will be an indicator that we were successful. I know, right? Usually you try to get rid of the contamination, but here we're going to rely on it to tell us that, yeah, we didn't get sodium vanadate, which is a pure white compound. Anyway, I'm going to go ahead and get this set up, and I'll come back when I'm ready to do the addition, and we will go ahead from there. Alright everyone, let me zoom in here a little bit so you can see it a little better. I just turned on the heat before I started filming this, so warm it up a little bit. That can't hurt. At least I don't think it can hurt. I mean, we do have to boil it afterwards. Okay, the instructions say to add this in small portions. Okay, yeah, I think heating's probably going to be required. Well, there's not a lot of liquid in there right now. I tried to keep it to the bare minimum. This is off, right? Okay. I don't need any more burns. Oh, shit. Alright, just spilled a little bit of dust there. Dust and aerosols are something that I want to avoid in this steel box that has fuck all for ventilation. Okay, hello. Stay focused. Alright, maybe need to add just a little bit of water here. Okay. You gonna fight me this morning, you stupid camera? Probably. It does all the rest of the time. Why would this morning be any different? So you can see it doesn't, especially once it starts warming up, it doesn't take long at first. As it keeps going, it will take longer. I don't want to overdo it here. Kill the heat. So I'm sure the reaction is producing heat, and that's only a small volume of water to actually absorb it. I'm going to add a little bit more here. I mean, we're going to precipitate it out with alcohol anyways. It'll be fine. All I need is enough to do this experiment, and it would be nice to have some left over, though. Oh, shit. Dog canopy emergency. Sorry. Those canopies are what keep the other dogs dry, which is what allows them to have electricity, which is what allows them to have heating at night. And I mean, it's winter, their pits, I mean, they've got that really short pit bull fur. They can't be out here without some kind of heat at night. I know I wouldn't want to be out here without some kind of heat at night. And I'm sorry, any philosophers watching, yeah, and pondering the question of, does a dog feel like a human? Yeah, they fucking do, okay? It feels cold to you, it's cold to them. It really annoys me when people leave dogs outside when it's freezing fucking cold. Well, their dogs will be fine. No, motherfucker. No. If you feel cold, they feel cold. I mean, if the dog has a really thick fur coat, sure, then fine, yes. You know, I have a dog that's like that, where I don't worry about him being out in the cold too much. Although, he's way too spoiled to sleep outside. That dog would be like, bitch, please, I'm coming inside. But that's my retriever that I've had for, well, it was 5 years the day after Thanksgiving, so he's my buddy. He's also one of the most stubborn, willful little shits. That dog thinks he's a person, which is a notion I guess I haven't done a whole lot to dissuade. Now this is interesting. It's almost a kind of ever so slightly gray tinge. Orange or yellow I could see, but I wouldn't have thought it would be this dark. Alright, it is boiling, kids, and there is definitely some kind of solid in there that was not described in the method. So, there is some contamination. That's alright. Alright everyone, this is the solution that I got. Well, I say solution, more like a suspension, after I filtered it. The solids that we were seeing, it was this brick red solid. There was only a little bit of it in there. I'm not 100% sure what it was. Maybe unreacted pentoxide, maybe some other contaminant. I'm honestly not sure. Anyway, we are going to go ahead and try to precipitate out the sodium metavanadate. Now, the reference I've seen just says that it's insoluble in alcohol. It did not say which one. So I'm going to try methanol at first and see if this works, because methanol is cheaper than ethanol. Looks like it. Alright, fantastic. That worked out pretty well, actually. Probably should have done that with some stirring so I don't end up with super fine particles of it. Oh well, too late now. No, that's not bad at all. Sweet, I thought this was going to be a disaster, but this is about what I would have expected, a slightly off-white powder. It should be fairly heavy. Tell you what, let's add a little more. Like I said, methanol is cheap. Oh, there we go. Oh, that's even better. Shit. Hell yeah. That's what I'm talking about right there. Yeah, you can get pretty decent purity methanol at the auto parts store. Sold as that. Actually, I'm not even sure what the hell the use of that stuff is. I think it's for if your engine freezes up, it's for de-icing it, I think. I don't know. Auto mechanics is not my area of expertise. Alright everybody, I learned something very important while doing this synthesis, and that is, do not do it in an Erlenmeyer flask. After you add the alcohol, the sodium metavanadate will solidify. It doesn't crystallize, it solidifies into like a plate of sodium metavanadate on the bottom of the flask, and it becomes very, very difficult to break up. I was able to break some chunks off, and I filtered it and dried it under vacuum. It's not completely dry, but it's mostly dry. It's just slightly damp, and I think we can go ahead and use this. The reaction is going to be carried out in water anyway, and I'm pretty sure that most of the methanol has been removed. But yeah, so I ended up having to dissolve the rest of it back in water and then reprecipitating it with alcohol. And I don't know, I think that the pH may have gone too low, and because it's not slightly off-white like this, so I'm still saving it, but for now, I mean, I'm calling this the metavanadate that I got. Yeah, so if you're not repeating that synthesis, very important, do it in something where it's going to be easy to scrape that shit out of afterwards. Not a 500 ml Erlenmeyer flask that it is really hard to reach down in there. So, important little, important thing to know. The vanadate didn't do that. As you can see, the sodium vanadate, it also solidified into chunks like that, but I didn't have as hard of a time breaking them up and getting them out as I did with the metavanadate. And I don't know why. That could be because of the choice of alcohol, that could be just because the gods were angry with me. I have no idea why. So anyway, like I said, I'm trying to recover the rest of the metavanadate, but this is 9.92 grams. Again, it's slightly damp. And we can go ahead and do the polyoxometalate compound with this. So that's what we're going to do. And I'm going to come back once I've got that one ready to go. Alright everyone, so here is our attempt to make this polyoxometalate. Now, this is very similar to the other ones that we've done in the past. This is my solution of sodium metavanadate. I know it's very cloudy, but I mean, I filtered it and this is as good as it's going to get. So, we're going to put it up here. The protocol does say that we can heat it a little bit if we need to, but that this is not stable to heat, so that we do need to try to keep the temperature to a minimum if at all possible. So what I've got there, go ahead and get it stirring. Alright, now what I've got here is a solution of dibasic sodium phosphate. The amounts of everything are down at the bottom of the screen. And here, nitric acid. Alright, nice dark red. That is what we are supposed to get. Yay! That is a step in the right direction. Now, the protocol says that we can add acetone to this and then let it sit in the cold in order to get everything to crystallize. There are some other salts of this that we can make, and I figured we could do that. I am going to go ahead and get a sample of this to do a crystal film with it, which I will put up after the end of the video. And I don't know if I've ever showed you guys, but this is how I do that. Dilute that down a little bit, and then I will put that under vacuum over molecular sieves, and then I will get some pics of it under the dissection scope. So anyway, we should have right at about 30 mils of this. Okay, so here is a solution of potassium nitrate and ammonium nitrate, and we're going to add 15 mils of this to each of these solutions, or rather we're going to add 15 mils of this to this, as soon as I can get my little graduated cylinder here so that we can at least make it somewhat accurate. Okay, here we go. So we've got about 15 mils of this stuff. Alright. So there it is, mixed with the ammonium salt. And now for the potassium salt. There we go, there's our potassium nitrate solution. Okay. So that should have the volume of each of these at about 45 mils. 1/5 of that is 9 mils. So we will need to add 9 mils of acetone to each of these, and then allow them, we'll stir them, then let them sit in the cold. Okay everybody, I'm sorry for the shaky cam, but there's really no other easy way to do this. So this is the potassium salt here being filtered out. As you can see, it's almost it reminds me, it's like the color of tomato soup. That's what it reminds me of. And over here we have the ammonium salt, which is a nice dark red. You can see them better on the beakers that they came from. The ammonium salt there crystallized on the sides of the beaker, and of course on the stir bar there, which I will try to get some shots of at least the stir bar under the scope as well. The crystal films all turned out very nice. Although I would think is interesting is with the ammonium salt, and I didn't see this with the potassium salt, but you see that there is a red and a yellow compound. That was present in the crystal films as well, and you'll see after the end of the video if you stick around and watch those and see the pics. So anyway, but the ammonium salt, like I said, is a nice dark red. The crystals are fairly large, nice and heavy. If I was to do this again, I would go with the ammonium salt over the potassium salt, just because it looks nicer and it just looks like it's a little easier to handle. So Anyway, I will come back when I've got the solids isolated here. We'll take one last look at those, and then that'll be it for this experiment. Alright everybody, here we go. These are the final products. This is the ammonium salt here, and this is the potassium salt here. And this still kind of looks like rust and tomato soup to me. That really is like a tomato soup red brown. But anyway, there you go. We have successfully created 24 vanadic acid 2-phosphates, the ammonium and potassium salt. We have isolated them. We have viewed their grandeur and their glory. So, yay! I hope that you've enjoyed this. I thoroughly enjoyed doing this one, although it was kind of a bumbling clusterfuck, but no, it wasn't a fiasco at least. It wasn't chromium glycinate levels of clusterfuckedness, so we're gonna call it a success. If you liked this, give it a thumbs up. If you didn't like it, give it a thumbs down. And, subscribe, share the video, comment, please comment. And until the next one, which will hopefully be coming out in the very near future, I'll see you later.